So in this section, we begin to deal with more complicated types of motion. Motion that is not uniform. That means there's an acceleration in one direction or another. So we need to deal with those 6 big equations that are at the beginning of this section. And it will not be clear initially which equation to use. We have to come up with that based off of the information given in the question. So in order to do that well, the first thing we need to do is define the variables, everything that were given in the question, and everything that we need to find. So we have a motorcyclist traveling initially at 12 meters per second west. That is a velocity, and it's initially, so that would mean that it is VI. Changes gears, speeds up for 3.5 seconds. This is our time. With a constant acceleration, dead giveaway, of 5.1 meters per second squared west. What is the motorcyclist's displacement over this time? Displacement is delta D. So looking at the variables we have, now we need to look back at that list of 6 equations and match up which one fits, having all of these variables and nothing else. Well, there is one that fits very well. Delta D equals VI delta T plus 1/2 A delta T squared. Substituting in VI 12 delta T 3.5, A is 5.1, and 3.5 again for delta T. That one is squared in the equation. Working this out, this isn't quite a one-stop shop to deal with it. We can do 12 times 3.5 gives us 42. We can work out the next term to get 31.2375. Adding those together and going to 2 sig figs, every piece of information we got was 2 sig figs, would give us 73. Displacement is measured in meters, and because it is a vector, we have initial speed to the west, acceleration to the west. Displacement will also be to the west.